All right, in this video, we are going to talk about rates of change and behavior of graphs. Actually, mostly behavior of graphs. We'll probably split out the rates of change into a separate video. Okay, so the first thing that we are going to talk about are increasing, decreasing, and constant. Here you can see the definition of increasing and decreasing. It is increasing or decreasing on an interval, okay, to be precise about it. And you can look at these definitions, but basically what increasing means is that the graph is going up as you go from left to right on that interval. Decreasing means the graph is going down from left to right on that interval. And constant means that the graph is a horizontal line on that interval. All right. So some things to always keep in mind, right, are first off is the perspective. The perspective when you're looking at a graph, trying to tell whether or not the graph is increasing or decreasing over a certain interval, then you would always go from left to right. That's the direction of increasing x. Okay, so don't go the other direction because you'll get all the answers exactly backwards. All right, so it's always from left to right. And like I said before, increasing on an interval just means that the graph goes up as you go from left to right. Decreasing means that the graph goes down as you go from left to right. And then constant means that the graph is a horizontal line. Okay, so that's what that means. But there is also one very important thing that you remember about the answers, how you would phrase your answer in terms of increasing, decreasing, and constant. They must be given in terms of the x-axis. All right, and that is a little bit counterintuitive. Most of the time, like say if you had to walk up a big hill, right, really steep, it takes a lot of effort. Most people don't focus on the horizontal distance that they have to walk, right? When you're doing that, you focus on the fact that you have to go up, right, a big hill. So you're focused on the vertical direction. So, to me, it makes sense why people have trouble with this, and that's because it's just natural for you to focus on up and down when you're thinking about increasing, decreasing, whereas x is the horizontal axis. So you might wonder, why do I have to report the answer like that, right? And the reason is a little bit hard to explain at this level, but later on, if you keep going in math, in Calculus 1, you will learn the derivative, and it will tell you where a function's increasing or decreasing or constant without having to look at a graph. And that is the way that the derivative tells you the answer in terms of the x-axis there. So it agrees with that and kind of gets you ready for that. Having the derivative, right, when you have that, it's a lot better than having to rely on the graph. Okay. All right. So I know that's in college algebra not a great reason, but I do think it's important to tell you the reasons why things are the way they are sometimes, are a possible reason. Because I wondered those exact same questions. Okay. All right. So first off, we are going to do some examples here. All right. So let me draw a picture of this, or get a screenshot so I can draw on it. Okay. And I will draw red. Looks good. Okay, so again, the perspective is from left to right, and so we want to start on the left side over here and keep drawing to the right. So with this particular graph, right, we can see that it has a filled dot right here, and then we can't really see any graph. So that basically tells us that the graph starts right here for all that we can see, okay? So, and as we work our way from left to right, we can see that the graph is a horizontal line until we get to right here. So the graph is constant, right, on this little piece right here. So what you would do, right, is give your answer in terms of these numbers right here on the x-axis. So this graph is going to be constant on the interval from -4 to -1. Okay. At that point, right, we can see that the graph starts going up, right? And the graph is going up as we go to from left to right. So it's increasing, increasing, increasing until it gets to here, right? And so again, remember our answer is going to be given in terms of the x-axis. So we would say that it's increasing from, and I kind of wrote over the number here. It's a little hard to see. So over this part of the x-axis right here, from here to here, we can see that from -1 to 3, the graph was increasing, going up as we go from left to right. All right, so it'd be increasing on -1 to +3. All right, starting back where we left off, right, at 3, then we can see that the graph is decreasing. It's going down, right, as we go from left to right. So we would say that it's decreasing from 3. All right, and the graph's going down, and we can see there's an open dot here. There's nothing that we can see over here. So basically, from the picture that we were given, and the fact that this is an open dot, right, the graph ends right here, right? For as far as we can tell, there's no graph over here, right? And so it would stop decreasing at 6. And the fact that this is an open dot means that there is not even really a point on the graph, right, at 6 at all. But there were points as close as you could get, as you want to get to 6. So we would put this as an open parenthesis in this particular case. Okay. All right, so that's where that graph is constant, increasing, and decreasing. All right, the next example. So constant, increasing, and decreasing. Okay, so starting off here, we want to start again from left and go to the right. We can see that this graph goes off the screen, right? And really what it should have is, it should have a little arrow like this. And that little arrow indicates that the graph keeps going down like that forever, okay, after. So the graph, right, as we start over here, it's going up, right? So it's increasing. So what we would do on the answer for this, right, is to put -infinity. All right, because the graph, right, keeps going off the screen like that. Let's see. And one of the issues about some of the Newton graphs is that they don't have those arrows on there. So let me see if I can pull one of those up without taking forever. And let's take a look at it just to verify. No, it's going to not act nice right now. All right, we'll keep going with this particular example. Okay, so this thing is increasing. Sorry, I'm still fiddling with this. Okay, I see the problem now. Wow. I'm just really being a pain. It will not let me pull that up. All right, give me just a second. Okay, well, that's pulling up. So, like I said, the graph keeps continuing over here, right, as far off the screen. And so we would say that the graph is increasing from -infinity. Right, you can keep going as far back as you like, and the graph would still be going up, even though it's off the screen like that. Okay. And then it keeps going up and keeps going up until it gets to right here, right? And so what we would say that it's increasing over from negative infinity, right, really far to the left, all the way over to 0. So that's where it's increasing. And then at 0, it starts decreasing, right? So here, it starts going down. And so here we would give our answer again in terms of the x-axis. So we would say that it's decreasing over this part, right? This part in here of the x-axis. So that would be from 0 to 1, okay? All right. And here, because of that filled dot, and we can't see any graph over here, we just have to assume, okay, the graph stops right there at 1, okay? All right, let's take a look. I finally was able to pull some of these up. Okay, so it does have, on the Newton graphs, it does have the arrows on there. Okay, so that is good. So that's not an issue. Maybe they went back and put those on there, which is good. All right, so all of that was for nothing, but that's okay. All right, and so that would be the answer on this one. All right, so I guess it's my graph that needs the arrows, so let's do Alt-Shift-W. All right, on this example, again, I should have arrows here. I do not, right? So I should have arrows drawn on there like that to indicate that it just keeps going up forever like that. All right, and so now what we want to do is determine the intervals over which f is increasing or decreasing. So we would start right over here to the left, and we can see the arrow continues, shows that the graph continues like this, and we can see that it's increasing, right? So we would say that this function is increasing, right, from minus infinity to, all right, and so if we follow this up, we can see that it stops increasing right up here, and so we would list that it's increasing from negative infinity to -2, like that. All right, then we can see after that the graph starts decreasing, right? So it starts decreasing at -2. Oh yeah, that's what I wanted to mention about this. So it starts decreasing at -2, and then it keeps decreasing, right, until we get to 4 right here. And then it stops decreasing like that. Okay. And then at 4, right, it would start increasing again. So I would just list this over here, like so. Starts increasing again. And this arrow, right, lets us know that the graph continues to increase like that. And so we would say it increases from 4 to infinity, right? Because, right, of the fact that it's this interval over here. You can keep going and keep going, right? And the graph's going to keep going up and up like that, right? And so now I remember what it was that I wanted to show you on this. So one of the issues, right, is that if you look at the answers here, and let me check my make sure I'm showing you the right. Okay, that's good. All right, so for instance, on this problem, they want to know, it says determine the intervals for which the function below is increasing, right? So it's increasing starting from right here, -2, and then it stops increasing right here. On this, it's decreasing and decreasing here. So the answer would be -2 to 0. If you'll notice on the answer that they have, they use parentheses instead of brackets. So you might have been wondering, hey, why did you use brackets? I'm normally used to using brackets. You use some brackets in your other answers as well. And you know, honestly, on this, it kind of depends on what book that you're using, how they exactly define increasing or decreasing. Okay, um, I think probably for this book's answers, they probably technically should have the brackets on there, but it looks like they mostly just give their answers in terms of the parentheses here. So that's just what I would do. Okay, let's take a look at a few more of these. On this one, right, you'll notice that Newton puts the union symbol on there. I don't do that. I don't think it should be there, right? Whether it can only be increasing on an interval, right, a connected piece, unless you then start checking how these the graph looks on these pieces relative to each other, right? So, and I don't think any of us want to get into that sort of issue, right? So I think that union shouldn't be there, but you'll see that they put that union symbol in their answers in Newton. So that's one other thing that I wanted to tell you about. Okay. It looks like most of the problems don't have are very similar to this last example that I showed you. So I think that is good enough so that you won't have weird things happening when you try to take this quiz. All right. So the main thing, if there's two intervals, it looks like they put the union right on that answer like this. Whereas I probably wouldn't do that. But if you're taking this on Newton, you should put that as the answer. Okay? All right. I think that is everything that I needed to tell you about. But let's just double check. No. Okay. So let's just go ahead and include this in here. So absolute extrema. Absolute extrema is the absolute highest point or the absolute lowest point on the graph of a function. Okay, and so if you take a look at this function right here, then this point up here at the very top, right? Whatever that point would be, it looks like 2, and whatever the y coordinate would be. So this point right up here. So this point right here, right, would be the absolute maximum point. It would be 2, and then I don't know what the y value is. It would be 5 point something. I don't know. Okay, that would be the absolute maximum point of this graph. Okay, and then this point has no absolute minimum point, and you can tell because no matter what point where you are on this graph, there's always, because of these arrows right here, the graph, it indicates the graph keeps going down. So you might think, hey, that's the lowest point. Well, no, it's not, because you can get a little lower, right? And a little lower and a little lower. So no matter what point you pick to be the lowest point on the graph, I can always find one that's lower. So this has no absolute minimum. Okay. So that's the absolute maximum point and the absolute minimum point. Okay.